Hello and welcome to another session. Welcome to another revision session for mathematics. For so far, the whole of this revision module will be covering from 2 revision questions, and I have another question, and that is on the topic of equation of a line. And the question is going to run through the screen. And I'd advise that you pause the video so that you can write the question down. And once you've written the question down, I'll be able to guide you through how to tackle such a question. Well, let's get started, and let me not take much of your time and wait for the question to pop up. I'll meet you after the introduction of this video. Okay, now I hope all of you are able to write that question down. If you're unable to, I advise you rewind the video and pause it, then you write the question down. Well, for those who have already written the question down, I'd want us to get started. And let's get started with the first part of the question. So let's see how can we tackle the first part of the question. Now, part A. So let me arrange my work in a more decent form that any student can be able to emulate. Now, part A of the question will be to calculate the gradient. Now, we need to calculate the gradient of that equation of line L. So let us get the gradient of L. Now, before we get the gradient of line L, are we given the points of a line L? Now, we're given the points of line L as -2 and 3. Then we also have -1 and 6. Well, with these 2 points, we can be able to get the gradient of line L. Gradient of a line is equal to the change in y with respect to change in x. Change in y will simply be, these are the y coordinates, 6 and 3. Points of a line are written in the form x, y. The y coordinate will be on this part, which is the second part. So that will be 6 minus 3 divided by change in x, which will be, now, since we started with 6, we have to start with -1 here. So we'll have -1 minus -2. 6 minus 3 is equivalent to 3. Then -1 minus -2. -1, now this will be +2, and that should be equivalent to 1. Therefore, the gradient of line L should be equivalent to 3. So the first mark will be awarded at this point. So here we'll have our M1. Then the final mark will be awarded here. So let's move to the second part of the question. And part B of the question is, find the equation of P in the form AX plus BY to be equal to C. Now, let us get the relationship between line P and line L. We notice that line L and line P are perpendicular lines. So if this is line L and this is line P, we notice that these 2 lines meet at an intersection point. Therefore, with respect to the relationship between perpendicular lines, we notice that the gradient of line L multiplied by the gradient of line P, this should be equivalent to -1. So let us get the gradient of line P, because we have the gradient of line L. Gradient of line L is 3. Gradient of line P is what we are looking for. and that should be equivalent to negative 1. Therefore, the gradient of line P should be equivalent to negative 1 all over 3. So we've already calculated the gradient of line P. Another thing we need to ask ourselves is, from the question, do we have any point on the line P? Yes, we do. And perpendicular to a line P, that question, we have another point here, negative 1 and 6. So this is also another point that line P and line L share in common. So they meet at this point, and the coordinates of this point is 1, negative 1 and 6. So let us get the equation of a line. You can easily get the equation of a line when you have any point and the gradient of that line. So we simply take an arbitrary or an imaginary point x, y, and we'll use it to calculate the equation of the line. And we all know that the gradient of a line, in this case which is negative 1 over 3, should be equivalent to change in y, which is y minus 6 divided by x minus negative 1. So this should be equivalent to, now this should be equivalent to negative 1 over 3 is equal to y minus x minus 6, sorry, not x, y minus 6 all over x plus 1. So we cross multiply. Whatever we have on the denominator here will cross over to the numerator, and the same to this other one. So we'll have negative 1 into x plus 1, then to be equivalent to 3 into y minus 6. Then from here we open up the brackets, and that will be negative x plus negative 1. Okay, so this is just the same as negative x minus 1 to be equal to, this one will be 3y minus 18. Remember, we are supposed to leave the question in the form of ax plus by to be equivalent to c. Therefore means we need to take this x on one side, it's already on this other side, so that is negative, let me adjust it where it should be, that is negative x. Now this 3 will cross over this side, it will be minus 3y to be equivalent to, now negative 1 will cross over to that side, it will be positive 1, therefore that will be negative 17. So that is simply how we tackle part B of the question. Let us move to part C. Now part C of the question, this is where many students began to freak out and start writing responses which were not coordinated. Well, let's get to the question, and let me break it down to a more simpler way. So you're told that another line Q is parallel to L. So let's imagine our line Q is here and our line L is here, and these two are parallel lines. What do we know about parallel lines? It therefore means that parallel lines in gradient of line Q should be equivalent to the gradient of line L. Okay, and from the question, what is the gradient of line L? The gradient of line L was 3, therefore the gradient of line Q will also be 3. From there, now let's get to the question, and this line Q is passing through a point 1, 2. So we have gradient of line Q, which is 3, and it passes through a point 1, 2. From there, now you're asked to get the x and y intercept. Before we get the x and y intercepts, we need to calculate the equation. Let's get the equation of this line Q. So equation of line Q will therefore be change in y, which is y minus 2, divided by change in x, which is x minus 3, and that should be equivalent to the gradient of Q, which is 3. Okay, then from there, when the gradient of Q is 3, we cross multiply that, so that will be y minus 2 is equal to 3 into x minus 3. Now from here we can open the bracket and simplify this such that I want us to write the equation in the form y is equal to mx plus c. So that will force me to take this to this other side. But first of all, let me open up this bracket. So I'll have y minus 2 is equal to 3x minus 9. And therefore, y, now this minus 2 will cross over to this other side. So it will be 3x. Now that will be plus 2. So negative 9 plus 2 will be negative 7. So this is the equation of the line of Q. So this is the equation of, let me say, LQ as line Q. Now from here, let us calculate or get the coordinates of the x and the y intercept. Now we all know that at the x-intercept, now this is where the line meets the x-axis. Therefore, the coordinates of y should be equal to 0. That is at x-intercept. Because if I draw a Cartesian plane and I cancel that line at this point, we'll notice that this will be the x-intercept and this will be the y-intercept. If this is the x-axis and this is the y-axis, the y-intercept is the point where the line cuts the y-axis, and the x-intercept is the point where the line cuts the x-axis. So at x-intercept, y should be equivalent to 0. So when I replace y with 0 here, what will be the value of x? So that will be 0 is equal to 3x minus 7. And therefore, I found the value of x. Therefore, x should therefore be equivalent to 7 divided by 3. Therefore, the coordinates of the x-intercept will be x is 7 over 3 and y is 0. This is the correct format of writing the coordinates of the x-intercept. Again, we go through the coordinates of the y-intercept. So the y-intercept will be, at y-intercept, x is therefore equal to 0. At this point, the coordinate of x will be 0. So I replace x with 0 here, and I'll have what? I'll have y is equal to 3 times 0 minus 7. Therefore, the coordinates of y here will be negative 7. Therefore, it is right for me to say that the coordinates of the y-intercept will be, when x is 0, y is negative 7. So this will be the x-intercept, and this will be the y-intercept. Kindly don't get tired. We're almost done. We're remaining with the last part of the question. Now, the last part of the question was to find the point of intersection of the lines P and Q. When you're told that two lines are intersecting each other and you're asked to get the coordinates of the points of intersection, the first thing you'll have to do is to write the equation of the two lines which are intersecting each other. Now, from our own calculation, we noticed that the equation of line P, let me find a place I can write it without the camera getting shady. So the equation of line P was, let me just check from my own calculation. The equation of line P was negative x minus 3y is equivalent to negative 17. This can also be written as I divide across by negative 1, negative 1, negative 1. I can also write this as x plus 3y is equal to 17. These two are one and the same thing. Okay, so this is the equation of line P. So I'll label this as equation 1. Then equation of line Q. The equation of line Q, we had done that and we noticed that we wrote it as y is equal to 3x minus 7. And therefore, I want to rewrite it in the same format. It is right for me to say 3x minus y is equal to 7. I simply did this, took this upper, negative 7. I placed it on the position where y was initially. So this will be equation number 2. So that is equation of line Q. From here we can solve these two equations because they are simultaneous equations. Simultaneous equations are equations which are meeting at a common point. And there are very many methods of solving a simultaneous equation. Now, oops, sorry for that. My camera just slid off. Let me hold it into the right position. So one of the methods which is the easiest to me is substitution. Many students tend to run away from this method. I don't know why, but to me I consider it to be the easiest and one that is most straightforward. So let's begin. In solving a simultaneous equation using substitution, the first thing we need to choose is one of the question and we'll make x the subject of the formula. So I'll pick the first equation and let me make x the subject of the formula. So I'll have x to be equivalent to 17 minus 3y. So this I'll label it as equation number 3. Then equation number 3 is replaced in equation number 2. Where there is x, I replace with this. So that will be 3 into, now 17 minus 3y, okay? Now minus y, okay? That should be equivalent to 7. Now from here, I open the bracket, 17 multiplied by 3. 17 by 3. So that will be 51. Let me check. 17 by 3 is 51. So here will be 51 minus this will be 9y. This is minus y and is equal to 7. From there, negative 9y minus y, this will be minus 10y is equal to, now 51 to the other side, it will be positive 7 minus 51. Now positive 7 minus 51, that will be negative 44. So we'll have minus 10y is equal to minus 44. Okay, therefore y should be equivalent to 4.4. Whatever I have as the value of y here, let me replace it at this point. Therefore, it's okay for me to say x is equivalent to 17 minus now 3 times y, which is 4.4. Okay, now 3 times 4.4, and that will be equivalent to 4.4 that will be equivalent to 13.2. So this is 13.2 minus 17. That should be equal to x. So x is equal to 17 minus 13.2. So 17 minus 13.2 should be equal to 3.8. So x should be equal to 3.8. Therefore, the coordinates of the meeting point should be x is 3.8 and y is 4.4. These are the coordinates of the meeting point of the two lines. I hope you enjoyed the video, and if there's any part in the video you are unable to understand, you know what to do. Also, let me know your thoughts on the comments section, and finally, don't forget to subscribe. Bye bye.